Okay, class, this is Mr. Scott. I hope you guys have enjoyed your time so far, staying at home with your families. I'm going to take this next 20 minutes to go over the assignment that you all had regarding the coronavirus. And I'll be posting more assignments for you guys to stay busy while you are on the corona break. All right. In this assignment, you guys had to do a couple of things. You were first to look at some headlines, analyze some real data to come up with a table. I kind of messed up. I wrote in some numbers for you guys, and they were a little bit off. I put 4 twice. Should have been only once. These are actual headlines that were taken from the news, and from these headlines, we can get some information. So basically, let's go ahead. I'm gonna go ahead and write some stuff in. Day 0 is actually March the 5th. On March the 5th, those are the first 3 confirmed cases of COVID-19 virus. So on March 5th, which is day 0, there were a total of 3 confirmed cases. Then 4 days later, which is March 9th, we had a couple of cases in Hartford. We had some cases in Montgomery County and PG County, which brought the total to 8. I kind of changed this headline. I merged 2 headlines on you all's paper. There were 2 separate headlines. I'm sure that was a little confusing for some people, but basically we had to add the 3 and the 2 up for a total of 5. 5 plus 3 is a total of 8. Or 5 days after the 5th, which is the 10th, there were a total of 9. And then by the 6th day, which would be the 11th, there were a total of 12 reported cases. Okay, that was the math there. And then you had to go to decimals, plot the points. I'm going to go ahead and plot some points on this graph here. I need to make a circle. Let me make my circle have, I'll make some red circles. And of course, those are pretty large, and I want to fill those in. Okay, so I'm going to shrink this circle and shrink it. Okay, so the first is at 0, 3. So this scale is by 1. So this is 1, 2, 3. I'm going to copy and make another circle for 4, 8. So grab this guy. 1, 2, 3, 4, 5, 6, 7, 8. And then 5, 9. So 5, it should go all the way up to 9. 9 total cases. And then for 6, there were 12. So there's 6, and I'm going to go up to 12. Okay, these are the points that were produced by raw data, okay? And you ought to take that, you were to go to decimals. Here we have decimals, those same points. I can change my window. I'm going to go from, let me go from 0 over to, I'll go to 10. And I'm going to go for my Y information. I'm going to go from, I'll go from 0 to, let me go to, I'll go to 60. Okay. So now, there we go. And we can see our 4 data points pretty clearly. There they are. Those are the 4 data points. And the data is pretty accurate. I mean, we hit 2 of the spot points dead on. We came very close. Our R squared factor is 0.98. Now, the closer that number is to 1, the better. Okay? 0.98 is pretty strong. There's a very strong correlation between the two variables that we're considering, which is number of days since March 5th and the number of cases. Okay, and we're seeing that the percent is about 25% per day that they're increasing. The initial value was 3. All right. So now what we want to do is continue with our activity. The first thing we had to do was we had to create the graph. We did that, plotted our points, and describe the relationship between the number of days since March 5th, 2020, and the total number of cases in Maryland. Okay. Now, I'm going to go ahead and type on this. Okay. And guys, just to give you some input, the relationship between the number of days and the number of cases is exemplified, or we can say, because is that the number of cases is growing rapidly as the number of days increases. The relationship seems to be exponential. Okay. That shows that it's not linear. It's exponential. It's growing a little faster. Remember, linear, we have a constant rate of change. Rise 5, run 1, rise 5, run 1, rise 5, 1. But that's not what's happening here. Rise 3, run 1, rise 4, run 1, rise 6, run 1, rise 12, run 1. And that's what you'll see as time goes on. You're going to see that the number of cases that are happening in Maryland is growing very rapidly. All right, use the coordinates in the table to create an exponential function or regression model in the form y equals a times b to the x, where a represents the initial value and b represents the growth or decay rate. Use the following video. Well, you guys don't know that. Need to look at the video because you already know how to do it. Okay? And we came up with the equation. All right. Our equation is f of x, f of t. I'm going to go with f of t since we are. So f of t equals 3.09 times 1.25. What was that? 1.25. Let's double check. Yeah, 1.25. Now, I shouldn't say 3.09. I should say 3.1 equals 3.09 times 1.25. What was that? 1.25. Let's double check. Yeah, 1.25. Now, I shouldn't say 3.09. I should say 3.10 if I'm rounding to the nearest hundredth. 3.10 5 raised to the t. Because if my variable here is a t, this has to be a t. If I had an x here, this would have to be an x. Okay? Identify the initial value and the growth rate. Well, what is my initial value? Well, my initial value is how much we started out with. That is A. A represents the initial value, and B represents the growth rate. So our initial value is 3.10. Now, because we're talking about number of people, we really should make this an integer, but when we start dropping off digits, our model becomes inaccurate. So we're going to keep the 0.10, okay? Our growth rate factor is 1.25, okay? So that would satisfy that question. So all we had to do is identify. Okay. Now, what else are we being asked to do? Predict. We need to do a prediction. Use the regression function to. Now, this is good. This is use the regression function and your knowledge of logs to calculate the number of days since March 15 that it would take for the number of cases to reach 100. Well, number of cases. Which one of our variables represents number of cases? Is it f of t or is it t? Which one? Well, obviously t represents the number of days, so f of t, that's the number of cases, okay? So we're going to plug in 100 for the number of cases. Let's go ahead and see if we can do that. I'm going to have some fun with this thing. So 100 is being subbed in for f of t. 100 equals 3.10 times 1.25 raised to the t. Okay? And we're going to solve for t. All right? Now, I don't want to type all this stuff out, to be honest with you. So I'm going to see if they have a pen for me to be able to write with. And I think this is the pen. So let's see if that works. So the first person I'm going to get rid of is, I'm unraveling this. I want to solve for t. So who's furthest away from the t? This guy right here, the 3.10. So I'm going to divide both sides by 3.10. I don't think this is going to let me write it 3.10. Divide both sides by 3.10. You guys can laugh at me for... Okay. So I think if I... There we go. And I want this one to be hollowed out as well. All right. So dividing both sides by 3.10. Now 100 divided by 3.10. I'm going to pull out my calculator. Not that I really need it, but I just want to, save a little bit of time. And when I divide that, what I come up with is 100 divided by 3.1 equals 32.25 or 26 equals 32.25 or 26, 258 to be exact. No, it doesn't want to let me write that. 258 equals how much? Well, I'm going to be left with the 1.25 raised to the t. Come on, man. There we go. Raised to the t. All right, so the next thing I'm going to do is I need to hit both sides with a log. Remember, when we have our variable up in a tree, we want to knock it down. We need to hit both sides with a log. And I'm not even going to try writing this thing. I'm going to go ahead and type it. So basically, log of 32.258 equals the log of 1.25 raised to the t. Well, what happens with the fruit, the apple, when you hit it with the log? Well, it falls down. So what I'm going to do is just copy and paste. And this time, where's my log? Okay, now this wants to give me some problems. We'll see if I can. There we go. So now my t is no longer back here, but it fell down in front. Okay. And this is t times the log of 1.25. So now what I want to do is I want to get rid of this guy. So I need to divide both sides by log of 1.25. So now I'm going to divide both sides by log. So now I'm going to divide both sides by log 1.25. So log 32.258 divided by log 1.25 equals t. Because I divided both sides by log 1.25, right? So now let's go to Desmos and see what that is. Okay, Desmos, let's talk numbers here. Let me adjust the screen so you guys can see. This is what I want to know, Desmos. I want to know log of 32.258 divided by log 1.25. And that equals 15.5. So t equals 15.5. So I'm going to just add an equal sign inside there. Equals 15.57 equals 15.57. What does that mean in English? How will we translate that to English? Well, what that translates, this means that 15.6 days after March 5th, there will be 100 cases of that on March 15 plus 5, that's going to be 20. So March 20th, there will be 100 cases of virus. Okay, that's what that means. So around March 20th, we should expect to see around 100 cases. All right. And we will see if that holds up. All right. Now, how about what's next? What can you do personally to prevent the spread of COVID-19 in your community? All right, guys, this is where it gets personal, okay? But I'm going to answer this for Mr. Scott. I don't know about you, but for Mr. Scott, I mean, of course, there'll be some overlap. But we're all in different communities, and so for your community, you're answering for your community. What I can do personally to prevent the spread of CV-19 is, one of the things I want to point out to y'all is that you can list things like in bullet form. 1, wash my hands regularly. 2, avoid touching commonly touched areas in the community. I don't like how this is looking. I'm going to see if I can. Yeah, I'm going to switch it. There we go. Three, stay inside unless it is an emergency. Just stay inside. Watch some TV, read a book, do some IXL, play with my kids. Fourth thing that I can do is something that I've been doing. Make others aware of the importance of staying home. It is very important that we stay home, and some people don't realize that. They think it's, hang time or whatever, but the reality is every person should be staying home. And so I can help them to become aware of that and to practice that by sharing on social media my opinion. So those are 4 things that I can do to help in my community. How would the regression equation change if Marylanders practice safe habits like these that are named here. Well, of course, if we practice these things, this curve that we see, this is a pretty steep curve. This is a very steep curve. And if we practice safe habits, well, what will happen is this curve will shrink. For example, instead of what we have, y equals 3 times 1.25, well, what if y equaled 3? We can't change the past. We can't change the fact that there were already 3 people named at the beginning. But what we can change is the growth factor from 1.25 to, let's say, 1.10. What about that? 10 raised to the x. Now look at that. Okay, so instead of on day 10, instead of having, let's say we were talking about let's see, 100. Y equals 100, right? Y equals, we were talking about when it would take to reach 100. Well, it turned out to be 15 days. That's the 20th. Well, in the new model, it would take 36 days. That's like a couple of months from now for it to reach 100. Okay? Well, at the rate that we're going right now, we're going to be at 100 by the 20th in the month of March. That's just, 2 weeks after we, a week and a half, 1 week after we got out of school. We got out on the 13th. 1 week later, we're up at 100 cases. Wow. Well, if we practice safe habits, maybe that would be extended, so the virus slows down. And that's what we want. That's why we're asking people to stay indoors. That's why we're asking people to not go out, to not shake hands, to, practice safe hygiene so that we can flatten the curve. Okay? We want to bring down the growth rate. We can't change the initial value, but we can change the growth rate, or the rate at which it's spreading. If Marylanders practice safe habits, then the spread of the virus would slow down. The initial value would not change, but the growth factor would decrease. Maryland Governor Larry Hogan mandated the closing of all Maryland schools from March 16th through the 27th. How will this impact CV cases in Maryland? Okay, so the number one thing that has been discussed is large gatherings. So when there are large gatherings, there's mass transmission. So by closing the schools, you are limiting the number of transmissions. So that's why we say, and they've also closed restaurants and bars, and because people don't want to stay inside, they want to get out. But the reality is, the more you get out, the more problems you cause. The closing of schools and other places of social gatherings will limit the amount of transmissions. Okay, so it's going to limit the number of transmissions. This will help the virus to die off sooner and allow us to get back to normal sooner with less infections and less deaths. Okay. Should the Maryland governor take additional steps to protect Marylanders, like closing all stores and businesses during this 2-week period to encourage individuals to stay home? Well, I kind of mentioned yes, they should take additional steps. At the time when you all received this assignment, they said no gatherings above, 500 and, some really bogus things, in my opinion. But the reality is that we need to take very drastic measures from the very beginning and all at once. Should the Maryland governor take additional steps to protect Marylanders, like closing all stores and businesses during this 2-week period to encourage individuals to stay home? Well, I kind of mentioned yes, they should take additional steps. At the time when you all received this assignment, they said no gatherings above, 500 and, some really bogus things, in my opinion. But the reality is that we need to take very drastic measures from the very beginning and all at once. All at once is the key term, because if not everyone is doing it, then it's going to spread. So we have to do it simultaneously. The governor needs to act big, and he needs to act simultaneously, and he needs to act quickly. It is important that the governor thinks big and acts quickly. Thinks big, acts quickly, and simultaneously. To prevent the spread of the virus. All gatherings should be forbidden. Okay, so if it's not necessary, don't do it. Stay home. Everyone should be encouraged to stay home and discouraged from going out. Well, what do you mean discouraged from going out? Well, DIS. I went to Costco the other day just thinking, oh, I want to get out of the house. Let me go to Costco, and I don't really need to buy anything, but I want to just, I'll go shopping. Well, when I went to Costco, there was a huge line of people standing outside of the building. And what they were doing is they were making people wait in line, and you can only go in, let's say, 20 at a time. And oh my goodness, when I saw that line, I was discouraged, and I said, you know what, I'm going to just go back home. So things like that, you make it annoying. Make it annoying to go out. And when enough people get annoyed, they're like, oh man, I'm going to just go ahead and stay home. It's too annoying to go out. And so that is the assignment. Because I'm going over this in its entirety, I will have to post a new assignment for you all. Now, I hope that you all have been following along with the news. It's been very interesting to track our model. Our model has been spot on for the first few days. Our model was spot on, and so the predictions were very accurate. Yesterday we ended at 85. We ended with 85 cases. Okay, so we are very close. So today's date is the 19th, 18th. Tomorrow's the 19th. And then we have the 20th, and it's predicted by the 20th we'll be at 100. Well, I honestly believe that we're going to reach 100 by tomorrow, if you ask me. So we'll be a day early. And basically, the new assignment is you're going to take newer data. Okay, I'm going to share with you guys more recent data, and you're going to look at the curve. Okay, and we're going to revise this curve. We're going to revise it to see if we can have a more accurate regression function. And it'll be pretty interesting to see how this information changes. So we had A being 3 and B being 1.25. Well, we got some updates, and we're going to see how that impacts the data. All right, guys, I hope you enjoyed this assignment. I hope you're staying safe. I hope you're learning a lot. Be safe. This is Mr. Scott signing out.